So what we are doing, we collect that low grade matter or the material that is extracted from the earth. We make one big heap over the wide range of the land, and that material is contacted with the solvent. So the copper is separated from the pyrites like this much big, like 6 to 8 meter tall, 120 meter wide and 800 meter long. Now that entire heap is contacted with the solvent, which is pumped, and drain pipe collect the leach solution, right? So this way leaching is helpful. Another important system that has been studied for the very effective leaching operation is the shank system. Of course, this is very important topic for university syllabus curriculum as well. Now there are 6 number of tanks. All 6 number of tanks are arranged like this, right? And it is a counter current leaching operation. It is a counter current leaching operation. So what happens? In counter current leaching operation, the solvent becomes strongest in terms of solute as compared to cross current operation. Counter current is high efficiency than the cross current operation, right? So instead of moving the solid, the liquid is transferred. So very first top point to be understood is that all 6 tanks, solid will remain there only. Only liquid is passed out from one tank to second tank to third tank, and so on. Right? We studied that in detail. But you have to understand there are 2 things, solid material and liquid material. Now solid material is not moving anywhere. Solid is stayed inside that tank only. But liquid is collected in one tank, perform the leaching, and then transfer to the second number tank, right? So there are 6 tanks used for the operation. Now as per figure A, consider that tank number 6 is empty and 1 to 5 is filled with the solid. The tank 5 just before 6 is recently filled with the solid. Okay, so there are high number of solute available in fresh solid, right? Because it is not extracted before. The leaching has not been performed just before. So what happens? The tank 1, at that point when the tank 6 is empty, the tank 1 has the longest time of solid, because there are fresh solid is added in tank 5. So tank 1 is the highest leaching operation performed, right? And it has most concentrated solvent is added in the tank 5, right? So fresh solid is contacted with the 5th time solvent, the mixture that comes from the first to 2, 2 to 3, 3 to 4, 4 to 5. So already the liquid has performed 4 times extra leaching, and we are adding to the fresh solid. So that's why it is known as counter current operation, right? Why counter current? Because fresh solid is contacted with the maximum solvent that has been used, right? So this fresh solvent is added to the tank number 1, and the concentrated solution is extracted from the tank number 5. So that is the reason why this is called counter current operation. When this done, the concentrated solvent is taken out from the tank 5, because in tank 5 fresh solid is added, concentrated liquid is added. this concentrated liquid becomes more concentrated because there is a fresh solvent, fresh solid, and so on. So that fresh solid take out can give maximum amount of solute, and that liquid is separated. So you can see in figure number A. In figure A, the concentrated solution is taken out from the tank 5, and fresh solid is and a fresh liquid is added to tank number 1. Correct? Now, what happens? We take out that liquid from the tank number 5, and then we can move that tank number 4 liquid to 5, 3 to 4, 2 to 1, 1 to 2. So now the cycle becomes as per figure number B. As figure B. So now the fresh solid which was added in tank number 6, which was just emptied, the solid is taken out from the tank number 1 because it was leached out for 5 times. Now the solid is taken out. It is known as spent solid. Right? So after 5 times, the fresh solid is added into tank number 6. Again, in next turn, what happens? In next turn, what happens? The spent solid is taken out from the tank number 1, and liquid is transferred from 5 to 6, 4 to 5, 3 to 4, 2 to 3. So now remember what happens to tank 5. In tank 5, previously we have added fresh solid. So it was leached out first time. Now liquid is transferred from 4 to 5. So again it was leached out. So it is a second number of time. This way 5 times the liquid is contacted with the same solid, which has low amount of the solute. Clear? So this way the counter current operation, and continuously solid is taken out, fresh solvent is added, and concentrated solution is taken out. So this way we can get the maximum amount of leaching. So this Shank system is very important. Right? If you have any doubt, you can write or coordinator will convey to me. Okay. So this is the Shank system. This system is very useful in industry. Now, there is equipment, leaching equipment. There are basically 4 major equipments that industry are using for the leaching. Right? Apart from this tank system, like Kennedy extractor, continuous counter current decanter, rotocell, Ballman extractor, these all types of equipments are used in the industry. So we go in a not detail but in a brief. So how the Kennedy extractor works. So this is the figure of Kennedy extractor. Same way the solvent is flowing from this side, from right side to left side. Right? And solid is traveling from the left side to right side, and from the drag chain conveyor, the solid is taken out. Right? So this is the extraction performed with the Kennedy extractor. Right? So what happens in Kennedy extractor? the solid is traveling from the first fins to the second fins, right? So this type of solid flowing is performed in the Kennedy extractor, right? And the spent solid is taken in the discharge. The spent solid is taken in the discharge, and the fresh solvent is added there. So this is also a counter current operation. This is also a counter current operation. So what happens in Kennedy extractor? The leaching is done in the stage-wise operation. The solid is pushed in the tubes by movement of pedals, and the solvent is flows in counter current operation. So perforation of solid between stages from pedal is possible. So number of cascade tubes are connected in the series. So these are the cascade of the tubes. This is the cascade of the tubes, right? And this can be traveled. The second operation is continuous counter current decanter. Continuous counter current decantation. What happens in decantation? If you see, the leaching solvent is added from the right side, from tank number 4, right? The solid is added in the tank number 1. The solid is added in the tank number 1. So again it is a counter current operation, from where the sludge is traveling from the underflow and it will fed to the tank number 2. The sludge means solid. So that solid is traveling to the tank number 2. While the solvent is added from the tank 2 to 1. So from tank 2 to 1, and the solvent is traveling using overflow. And in underflow, the sludge is traveling. Again, from tank 2 to 3, the sludge is traveling from the bottom and solvent is traveling using overflow. Right? So this way, in counter current manner, continuous counter current decantation is worked. It is also very high efficiency equipment. Right? But you can see there is pumping cost, there is equipment cost. So we have to optimize which equipment we need to use in which type of experiment. Right? So the overflow is for solvent or solution of solvent and solute, and the underflow is for sludge. So this is the same thing that has been written. So in phosphoric acid or phosphate rock with sulfuric acid, for the phosphoric acid we can use continuous counter current decantation, right? The another thing is the rotocell. Now I am not going into detail because the time is not permit me, but you can see the figure. It is a similar kind of arrangement, but with the rotation of the compartments. So there is a little difference than the continuous counter current decantation, where there is a 4 different reactors were there. But this is rotocell. There is entire compartment is prepared and that compartment is rotating. So that way the solvent is leached out and spent solid is taken out. Right? So this way rotocell. Another experiment equipment is the Ballman extractor. Now this also useful in the number of industries. Now what happens in the Ballman extractor? The solid is inletted from the top of the equipment, right, and it will travel from the entire section from the right side, then it will go to the bottom, and then it will come out as the top. Now if you see a light green color shadow is represented over there, so it is a spent solid. What happens to the spent solid? That the solid is leached out maximum. There is further no more scope of the leaching. So that solid has to be taken out. So there is a screw conveyor at the top which collect the spent solid and it get discharged from the top. Again it becomes empty at the top, and when it moves to right side, it will again fill out with the solid. So this way we can move solid. Now another thing we need to understand is solvent. How solvent is moved? So liquid is pumped out from the bottom and it will added to from the top. So solid is added. After solid addition there is a liquid, and liquid will flow in the downward direction. So from one side used solvent is added, from the other side there is a fresh extractant or solvent is added, right. So one side is fresh solvent, right, where the solid is already leached out, so there is less amount of solute. But from the right side there is 50% extracted solvent which has some amount of solute in it, that needs to be used with the fresh solid, So this way we can perform the counter current extraction, leaching, right. So this is also solid liquid leach extraction, we can also say in leaching. So this way Ballman extractor is very useful. So this type of extractor widely used for the extraction of vegetable oils from the seeds, right. Consists a number of baskets. See, that segment is called basket, fixed onto an endless chain having descending and ascending leg. One side is going downward, one side is going upward, enclosed in vapor tight chamber. Each basket has a perforated bottom. Perforated means the liquid can travel from that basket to the another basket, and at the end it will collected at the bottom, right. Then see, if you observe minutely the descending leg, that is the right side one, which has 50% extract, it collects as a full extract and it is separated as a out product. From another side there is fresh solvent is added. Now that fresh solvent is collected as the 50% extract and it is recirculated. Right. So from one side it will go to downward and that fresh is again recirculated from right side. So this is also again a counter current operation. But not exactly the type of decantation type, right. But this is also known as in counter current, right. The solid fed through the hopper into the basket at the top of the descending leg and partially enrich the extract is sprayed on the solid, right. Just I have explained that. So that way the solid is collected. The liquid is percolated through the slowly moving basket and collect at the end of one bottom sum of the unit. The fresh extractant is sprayed on the top basket in the ascending leg and percolate through the rising basket and collect in the another sum at the bottom from the 50%. Right? The percolation of the liquid occurs countercurrently and percolation of the liquid occurs countercurrently and the descending leg and co-current in the ascending leg. Right? So this way it is reducing from one side, it is countercurrent, in another side it is in co-current. This is also very large leg, like 15 to 20 meter high. Right? So it's a very tall equipment. So at the top of the tower the baskets are tipped into a hopper which is provide a screw conveyor, and at the bottom to discharge the spent solid. So solid is collected at the bottom. Right? So there are few advantages of ball mill extractor. There are few advantages of ball mill extractor. Number one, it can be integrated into continuous process, right? So a continuous process where it can give us the one side input, one side output, continuously product is formed in leaching. Second, it is very high efficiency. The solid liquid extraction is very high and it is very concentrated liquid is collected at the end. There are some disadvantages like cost of equipment is very high. Second, large equipment is used to maintain the optimal thermal profile in the maintaining the thermal profile optimal throughout the equipment is very difficult, because I have just mentioned in the early of the webinar, the temperature is very crucial role in the leaching. So if we have to maintain high temperature, it is very difficult in the ball mill extract. Right? The third thing, the hydraulic conductivity is low and it is impaired percolation. Sometimes channeling through leaf matrix also occur, which also have adverse effect on the efficiency. So these are the general disadvantages of the ball mill extractor. Clear? So I think most of the equipments are clear. Now moving to the material balance. When I say leaching of the solid, then there are two important things. One solid is soluble in the solvent. Now another solid is insoluble. So the insoluble component remain constant. Like consider this circle as a equipment, and solid to be leached is filled from the top, from the left side, and the solvent is also added. So we have in feed capital F mass, that is our feed of component A and C. The capital B is the insoluble solids, and from that there is mass fraction of B available in the mixture. Now what we are doing, we are leaching using solvent. So that solid is removed, that is the leached solid is taken out. So two output. First is the leached solid that has very less amount of solute, or maybe say no amount of solute, and the solution that has very high amount of solute plus solvent. There won't be any insoluble solid in the solution, right? So The figure is a single stage operation. The capital B is the insoluble solvent which remain constant for the operation. The quantity is B is calculated as mass fraction of B into feed, that is F. So NF is the mass fraction of the feed. We can say is equal to E1 into N1 because it remains similar in the leach solid and feed solid, both the insoluble solids that remain constant. Second, the material balance, the overall material balance. So how we can write the overall material balance? So there is a feed mixture, capital F. The RO is the leaching solvent and there are two outputs. First is the extract E1 and the another is the R1, that is the solution. So E1 and R1. So F plus R0 is equal to E1 plus R1. Now, if we do the solute balance for the single stage, solute balance means our solute C. So that C compound has to be extracted from the solid. So feed into YF. YF is the mass fraction of solute available in the feed plus R0. What is R0? R0 is the solvent quantity. So R0 into X0. X0 is the mass fraction of solute in solvent. It might happen that X0 is equal to 0. It might happen. But in equation we have to consider it. If sometime we use recirculated solvent, then we have some 1% or less than 1% solute. In output, E1, that is the leach solid, into Y1 plus R1 into X1. So R1 is the solution and that has X1 amount of the solute. So this X1 is our target. If you are doing a leaching operation, please consider that X1 has to be maximized. Then and then the effective leaching is said to be performed. If your leach solution has lower amount of solute, then it is not useful operation. Right? So this is the solute balance. Now, when first what happens? The leach and solvent both get mixed. So M1, what is M1? M1 is the mixture. So mixture is mixed. Now that M1 is mixed and we have NM1, which is the mixture solvent, right? And that has the mass fraction of YM1. So this relation gives the relation for the mixture of the single stage leaching operation, and the quantity of solute leached from the single stage leaching is calculated from the above equation. So I guess the almost 4 o'clock is near, and most of the topic that I have considered is covered in this presentation. So if there is any query, then I am happy to answer that as well. So yeah. Nitesh sir is here?
Yes, sir. Hello. Can you hear me?
Yes, sir.
Okay. So, no one received in message. कोई क्वेश्चन आया नहीं है अभी. Hello.
Good. Maybe everything is understandable. Anything is not understandable.
तो 1-2 मिनट के लिए हम वेट करते हैं.
Yeah.
ओके.
4 વાગી ગયા પાક્કું તો કેમ નીચે આવી ગયા એટલે નીચે આવી જવાનું બેસો બધા 5 મિનિટ રહીને આવો.
ओके. किसी ने अभी नहीं मैसेज किया है. तो बात नहीं, ठीक है. तो we sincerely appreciate you for taking out time from your busy schedule to provide us with such valuable information for the leaching and everything of leaching information and the advantages of leaching and some leaching operation, material balance and component balance and overall material balance. The seminar earned a huge positive response. All thank you to your support. And on behalf of Parul University, thank you. Thank you very much, sir.
થેન્ક યુ સર.
Okay.
થેન્ક યુ.
Okay, sir. Thank you.